All right, so we're going to review factoring, and right now this is going to be factoring by GCF. So remember, when we're factoring, we're doing the opposite of when we were distributing or foiling, so we're pretty much undoing that. So when we factor, we divide out. All right, so let's look at our example 1. Negative 18y to the 4th plus 6y to the 3rd plus 24y squared. So I'm going to go over this using the F method. So that's where we're going to draw a big F around our polynomial. All right, so now we're going to look at the 3 coefficients that we have in front of each of our variable. So I have negative 18, positive 6, and positive 24. So this is where we want to factor out a greatest common factor. We're going to factor out a term that can go into all 3 terms. So between negative 18, 6, and 24, the greatest coefficient that I can factor out is a positive 6. So when I factor that out, I'm dividing it out. So negative 18 divided by 6 is going to give me negative 3, and the y to the 4th is still attached to it. Plus 6 divided by 6, well, anything divided by itself is 1, so I have 1y cubed. Plus 24 divided by 6 is going to give me 4y squared. All right, so now we're going to look at each of our 3 terms that's on the inside and determine if there's anything else that I can try to factor out. Well, each of these terms still have y's. So we can still factor out a y. So if we look at each term, the first one, well, that has 4 y's, the second one has 3, and my third term has 2 y's. We have to think about how many y's can I factor out of each term. Right? So I can factor out at least 1 y from each term, but I can also factor out at least 2 y's. So if we look at our last term, we have y squared. Well, I can pull out y squared from there. My second term, the y cubed, I can pull out at least y squared from there. And my first term, y to the 4th, I can pull out at least y squared from there as well. So that's what we have to factor out from the second part. So I'm going to factor out y squared. And when I divide that out, remember when we're dividing variables, we subtract our exponents. So when I have y to the 4th, I'm dividing out a y squared, we're left with y squared plus 1 y to the 1st plus 4. All right, so if I take a look at my terms, there's nothing else that can be factored out. There's nothing else that we can factor out at all. So what we have on this left-hand side, on the outside, well, that is our GCF. And when we do with the GCF is we just multiply them together. Right, and then what we have on the inside here, that goes inside our parentheses. So we write our factored form as 6y squared, parentheses negative 3y squared plus y plus 4. So this is our whole answer. That's our factored form with a GCF of 6y squared. Okay, so now we're going to factor trinomials when a equals 1. Now remember, the standard form of this is ax squared plus bx plus c, where a, b, and c are all just integers. All right, so let's look at our example. We have p squared minus 15p plus 50. Now, the number in front of my p squared, my first term, that's a 1. So we're only factoring right now when a is equal to 1. Our b term is negative 15, and our c term is positive 50. So this is where we made the chart. If you remember how to factor and you don't need to write the chart, that's perfectly fine. Remember, what goes on the left-hand side are our factors of C, and then on the right are that adds to our B. So if we look at our C term, well, the 50 is my C. So we're going to place 50 over here on the left of our table. And then if we look at our B term, well, the B is a negative 15. So the negative 15 is going to go onto the right. All right, so first we want to list our factors of 50. So we have 1 and 50, 2 and 25, 5 and 10. Okay, so we're going to look at each pair of our factors of C. Now, they have to multiply to a positive 50, but they have to add to a negative 15. So if we think about it, a positive times a positive gives us a positive. But a positive plus a positive is not going to give us a negative. So the only way that we can get that outcome is if both of our terms are negative. Because if you think about it, a negative times a negative is a positive. And if we add two negatives, well, our answer is still negative. So we're going to add our pairs of factors together and see what they add to. Because our goal is to get one that adds to this negative 15. So negative 1 minus 50 is going to give me negative 51. It's not that one. Negative 2 minus 25 is negative 27. It's not that one. And negative 5 minus 10 is negative 15. So there we have it match. So these two numbers become our factors. All right, so we write our factored form as p minus 5 times p minus 10. Right, and you can always check your answer by distributing. So if I have p minus 5 times p minus 10, well, I can distribute. P times p is p squared. P times negative 10 is negative 10p. Negative 5 times p is negative 5p. Negative 5 times negative 10 is positive 50. Well, if I combine my like terms, my two like terms are in the middle. So p squared minus 15p plus 50. And that's exactly what we started with. So that's how we know that we have factored it right. All right, example 2. V squared plus v minus 12. So I'm going to quickly draw my table. I want to find what multiplies to c, which is negative 12. And what's going to add to my b, which is positive 1. Again, if you don't have to draw the table, if you know the factors right away, then just factor it. Okay, so we're going to list our factors of 12. We have 1 and 12, 2 and 6, 3 and 4. Now we have to look at the signs of our coefficients. So they have to multiply to a negative 12, but add to a positive 1. So that means one of these two signs is going to be negative. We have to figure out which one is going to be negative. All right, so let's look if all my smaller numbers were negative. If my smaller numbers were negative, well, a negative times a positive is going to give me that negative 12. And if I added them, well, negative 1 plus 12, that's going to give me a positive 11. So that gives me a positive answer. That's what I want. Negative 2 plus 6 is going to give me positive 4. And negative 3 plus 4 is going to give me a positive 1. So that's what we're looking for. We were looking for a 1. If we did it the other way around and we made our bigger numbers negative, well, 1 minus 12 is going to give me negative 11, negative 4, and negative 1. These would give me negative numbers, and that's not what I want over here. I want a positive. right, so we found our two parts of our factor, so it's -3 and +4. So our factored form is just v minus 3 times v plus 4. That's it. All right, so example 3, we have r squared minus 4r minus 32. Now, the biggest thing to remember with these is you have to watch your signs, because your signs are going to be different for each time we're factoring these. All right, so our factors of c, so my c term on the left is going to be -32, and they're going to add to a -4 on the right. So let's list our factors of 32. We have 1 and 32, 2 and 16, and 4 and 8. So if we look at our factors, they have to multiply to a -32, but add to a -4. So the previous example, I kind of showed you quickly what happens when we make the bigger number a negative versus when we make the smaller number a negative. Well, here we want our answer when we add the two together to be a negative, so our bigger number has to be negative. And as long as one of them are positive, one of them are negative, when we multiply them together, they're going to give us a negative. All right, so I have 1 minus 32, that's a -31. 2 minus 16 is -14. And 4 minus 4 is -4. So that's what we want. These two numbers become part of our factors. And our factored form for this is r plus 4 times r minus 8. That's it.